Math.
What? Black.
Sweet stuff.
Black.
Sorry, I heard black. Okay. Lesson 95, nonlinear systems. We've graphed a lot of linear systems, right? If we have two equations that are lines, wherever they cross, that the coordinates of that spot where they cross is the solution that is common to both problems. Well, then we learned about nonlinear systems, and the equations that we were given, if we graphed them, would be a circle and a line. And so we would have two answers, one here and one here. Well, now, there are a couple of new types of problems we're going to get. One type of problem, the equations, one equation is going to be a hyperbola, and the other one's going to be a line. So two solutions, but it's the type of equation is a little bit different. Your procedure is pretty much the same still, though. You still want to take the easier equation and plug it into the more complicated one. So let's see what that looks like. Let's look at an example of that. 95.1. If we have 6x minus y equals 5, that was a line, and then xy equals 4, that one's the hyperbola. So this one looks like this, and this line is going to look roughly like that, except the line is going to cut through the problem. So like we've done before, let's take the easier looking equation and solve for one of the variables. I vote for whichever one is going to be easiest to solve for. In this case, do you think I want to solve this for x or y?
Y.
Because I want to know. Okay, y equals, and you can do that much on your own. All right, so once we have y, we're going to plug this into
Green. You heard green.
Yeah, not brown. Okay. So now that I have the easier equation solved for the easiest variable, I'm going to take what that equals and plug it into the other equation. So I've got x times y, which is 6x minus 5, equals 4. That's equals 4. So let's distribute this. We got 6x squared minus 5x, move the 4 back. That's a 0. And let's solve this for x. How do you want to do that?
The b squared. That thing.
That thing? Quadratic formula? Right. I've been doing this a little bit longer than you have, so I will do it quicker. Negative b.
Oh yes.
4ac, 4 times 6, 24 times 4, that's 96, over 2a, 96 plus 25 is, what, 121?
Like a million.
121, square root of that is 11. Okay, so x is 5/12 plus or minus 11 over 12. Let me just double check that. And, oh, the book did it differently. Okay, what do you know? And apparently my answer is wrong anyway. Oh, wait. 403. No, I think I might be right. Hey, I'm right. Excellent. Okay.
Oh man.
So using the quadratic formula on this, x equals this. Well, these are like terms. I don't have a radical and I don't have an I. I can combine these. So let's say what the two x's are. What's 5/12 plus 11/12? That's 16 over 12. And what's 5/12 minus 11/12? 5 minus 11 is negative 6 over 12, which reduces to 4/3 and negative 1/2. All right, so those are my two x values. Remember, so we set up the coordinates for our solutions. One x value, and remember which variable you're solving for. We solved for x. So these two possible answers for x I have to put in the x spot. One is 4/3 and the other one is negative 1/2.
Yeah.
So now that I know what the two possible x values are, I got to figure out the y that goes with this x, and I can use any of these equations Usually this, whatever we solved for like this, is usually the easiest one. We could use this one.
It's still the easy one.
Either way. Let's do this then. What's 6 times 4/3?
24 divided by 3 is 8. 8.
Uh-huh.
8 minus 5 is 3.
Is 3. Now, let's plug in negative 1/2 for x.
3 minus negative 8.
So there's our two answers, our two solutions.
Wow. There they are.
So that one is very similar to some of the previous ones we've already done. The only major difference is conceptual. Our nonlinear equation and it was a parabola or a hyperbola instead of a circle. That is for the purposes of solving this problem, that doesn't really matter to you very much.
Mm-hmm.
But nothing real major there. Now let's take a look at another scenario.
Scenario.
Are we gonna have to graph these out?
No, at least not for a while yet. Now the other scenario, I just like to show you what the shapes are so that you can have it, so you have it a little bit more of an understanding. Now let's say we had a hyperbola, look like this, and a circle. Let's say the circle. Pretend that's a circle. Pretend that we have a circle and a hyperbola that intersect like this. How many solutions are we going to have? 4. 2, 3, 4.
It's like an Easter egg.
Or if we have a hyperbola that goes this way and a circle, we can have it like this and have 1, 2, 3, 4 solutions. If we have a hyperbola and a circle that just barely touches, we might only have 2 solutions. So depending on how complex these equations get, we could have different numbers of solutions. So we'll just have to work them out and see what happens. All right, let's go somewhere else. Okay. So 95.2, if we have x squared plus y squared equals 9, that's a circle. 2x squared minus y squared equals negative 6. This is a hyperbola. I don't specifically expect you to know that, but just be aware that there's going to be, we're not talking about lines, there's probably going to be more than one place where they cross. Alright, well now both equations are kind of complicated looking. What should we do?
Like divide them.
Divide them?
Mm-hmm.
No, you can just you can take those y's out because it's
Exactly.
positive.
We've got 2 equations, 2 unknowns. You still have your 2 methods of substitution and elimination. Go with whatever's going to be easier for you, whatever's the most efficient. On some of these equations, if you just add the 2 together,
Oh yeah.
we can eliminate y,
Mm-hmm.
That's where it's happening.
and we get this. Well, that looks a lot easier. Now what?
One.
Divide both sides by 3,
Oh yeah.
X equals 1.
and now what?
Red.
Now it equals 1.
Red 1.
What are you doing?
All right, square root, and so x equals 1, right?
Yeah.
What did I forget to do?
Nothing. Absolutely.
When you take the square root of both sides of the equation, what do you have to do?
Oh, plus and minus.
Plus or minus. So x could be plus or minus 1.
Wow.
Wow.
So you got to do the
Okay.
box thing again.
All right, so let's set up our solutions here,
There it is.
because x could be 1
Uh-huh.
Or negative
negative
1.
1.
Wow.
Mm-hmm.
All right, so we got to plug each of these in for x in one of these equations.
Let's do that first one. Top.
Yeah, that top one looks pretty nice and easy. All right, so this first equation here, if I plug in a 1 for x,
Mm-hmm.
Yes.
what happens?
Well, it just becomes 1.
X squared equals
Then we've got y squared. The 1 squared is just 1. Subtract 1 from both sides. We have y squared equals 8. Then what?
Then
We're at 8.
Square both sides.
Plus or minus 8.
And you get 6
2 red,
4.
2
Plus or
red 2,
minus.
but yeah, plus or minus.
Wow.
So for an x of 1, y could be plus or minus 2 red 2.
No. Plus.
Yeah. What?
Plus.
Well, when x is 1, we had took the square root of both sides, which made us do plus. Because we've done an x of 1, and let's do another color. Just a mouse.
Let's do turquoise. Something.
What did you say?
A red, but it's hard
Maybe
kind of.
orange. Orange.
I'm going to do red. Alright, let's do an x of negative 1.
It's the same answer.
Negative 1 squared is also 1. Subtract 1 from both sides, and we're going to end up at the same place.
Wow, that's
Right?
cool.
Square root of both sides, plus or minus.
Y.
And so we're going to have y equals plus or minus 2 rad 2
Wow.
when x is negative 1. So plus or minus 2 rad 2 when x is negative 1.
And now we're done.
So how many total answers do I have?
4.
4. Now, can I leave it just like this?
Maybe
My answer.
you might have to graph it.
It's almost a really good rectangle, but you know, it's kind of.
I can leave this just like this because this shows all 4 solutions.
Mm-hmm.
Right? Positive 1, positive 2 rad 2, positive 1, negative 2 rad 2. This has a negative 1, positive 2 rad 2, and negative 1, negative 2 rad 2.
Wow.
If you want to write all 4 of them out, you may. You don't have to, but I could do this, and this, and this, and this.
Wow.
This would also be an acceptable answer. It's a lot of writing,
That is a lot.
This is quicker.
I like the box.
but one that I like to do, if it's all combinations of plus and minus 1 and plus and minus rad 2, I will also accept this.
That's accepting. Acceptance right there.
Because what does this mean? This means plus or minus 1 with a plus or minus 2.
I like
Rad
that
2.
one better.
Here's what to watch out for, though. If you have an equation or a problem that only has 2 answers, let's say if you write something like this, this means all 4 combinations. Plus plus, plus minus, minus plus, minus minus. If you have a problem that only has two solutions, you don't do this because this means four answers. So just be careful. I will accept this when there are 4 answers. So just be careful that if you want to do this, that's fine. Just make sure that you're doing it on the problems where that is the right answer. So there you have it. Solving systems of nonlinear equations.
Yeah.
Math.